step 2. Okay, for this week, we're mainly talking about branching. So what is branching? Well, it's one of the programming construct, right? Before this chapter, we are talking about programming in a linear fashion where the computer execute your statement from top to bottom. Branching added a little variety to it. So basically, computer will be able to execute the code depends on some condition you impose upon them, right? So we call it, if-else statement because so basically, if you reach some point in your code where there is some different process to compute depends on the condition, that's where you use branching. The branching in Python is really simple. It's like English, right? So basically you write if, else, if, and else statement. So each represent a block of code that will be executed when those conditions are true, all right? So for example, here in thy books, there is a example, a variable x, if equal to -1, you just print some statement, and if it's x equal to 0, you do another thing. You can do many else if here, right? As many as possible, and then final clause, you can use a single else to conclude your branching statement, right? So this is just some pseudocode for branching. So very, intuitive and very simple. Okay, now one thing you want to pay attention to is in Python, this if blocks, now you have a colon at the end, and that's critical. You can't miss that, right? The colon indicate the following indented block of code belongs to this if statement. In other words, so you have to indent the code after this line, right? Anything that is indented, that means this code is only executable when this if statement is true. If not, it will skip that and going to the next block of code that's not intended, all right? So in this case, it just will print your hotel rate. If your age is greater than 65, you can get a discount, right? Otherwise, you get a regular rate. So so that's something you need to pay attention to, all right? And same here, if you have else, then the statement will be indented here. That just simply means you're going to execute this if that statement is false. Okay. Yeah. So I think that's basically what you need to pay attention to in terms of the if-else statement. Okay. Python is very strict about indentation, so be careful about that. And then, if you pay attention to these, you will avoid a lot of headaches along the word. Okay. Down the road, I think I want to talk about some equality operator, equal. So we talked about comparing, two quantities, and you can use greater than, less than, and equal. The reason we use double equal is because the single equal is being reserved for what, right? For the assignment operator. So that's quite different. And yeah, the one thing I want to point out is that equal and is operator are different. So what's the difference between equal and is? Okay, so say, so I have two quantities. Let's say V1 is, say, ABC. Okay, it's a string. V2 is also ABC. Okay. Okay. So if I say V1 equal V2, guess what? I get the true statement. That means they are equal. If I say V1 is V2, I guess that's also true. So the reason is that they probably share the same memory space. Okay, let me give you another example. V1 is A, B, 1, 2, 3. Okay, so it's a list. V2 now is another list, also 1, 2, 3. Okay, now if I say V1 is equal V2, that's true. Okay, because the content of the list are the same. And if I say V1 is V2, it's false. So why is that? Why is that? Well, it's simply because every variable in Python has an ID associated with it, which represents some address in the memory that this variable is hosted. So if you use ID of V1, you can see there's a number, okay? ID of V2, there's another number, and they are different. So when you do is, that means the address of these two variables are compared. If they are the same, that means they're same object. So that's why V1, you can say is V2. And if it's equal, that means you compare a value. So although you have two different locations to store some data, but these data are the same. So equal will tell you they are the same, but they are not the same object except their content is the same. Okay, so that's the nuances of is operator and equal. So you have to be very cautious about that. Now, I think in Zai books, they talk about this in membership identity operators section, right? So, you can ask the Python to tell you if a certain key is in a dictionary by using the keyword in, right? Or you say if letter in a string, if element in a dictionary or list, you can all use the operator in to give you the binary result, a Boolean result, true or false. And identity operator is not, sometimes the program wants to determine whether two variables are the same object. The programmer can use identity operator, right? So is means these two are identical. And then, so these are described here in this section. Order of evaluation. If you have a combination of mathematical operation, parentheses, and relational operators, like a member operator, logical, what's the precedence? Excuse me. So here is the tree of hierarchies. So basically what happened is a computer actually has an actual tree here. To the Python interpreter will have constructed a tree as a priority data structure, and it will treat the leaf. We call this is an inverted tree. Like computer science, there's the tree is inverted, so this is the root of the tree, and these are the leaf of the tree. You will learn about tree in your data structure course. So basically, on the leaf side of the leaf, we call this leaf nodes, right? So on the leaf node, they are processed first. So x plus 1, this plus is basically the operators, and it operates on the two children. Now, x and 1 will be operated, and then y and z times z, and then they are compared against each other. Then in the same time, the z3 and 3 are compared if they're equal. And the final result will be OR together. So OR is the last operator to be evaluated, okay? And of course, if you add parentheses on those, it will change the order. And you sometimes should use parentheses if things are not obvious, okay? Like not x equal 3. If, it's better to put parentheses on to make it more obvious, okay? So yeah, and like I mentioned, the code blocks and indentation is super important in Python. So make a habit of checking your indentations. Don't forget the commas, right? You can nest your if statement inside the if statement, but I don't recommend you have like more than 2 or 3 layers of a nested loop. Usually you can accomplish the same thing without the loop, without the branch, right? Without nested branch. Okay, so so yeah, like this example, the if and else should on the same level, indentation level. If you indent this, wait a second. Okay, so the print should be indented. Otherwise, it's not part of the if statement, right? You have to indent further. And this else should be flush with that other if. Okay. Yeah. So sometimes Python has a one-liner type of syntax that make your code more succinct. Like for example, you can shorten this if-else statement, like 4 lines, into 1 line. Basically, you would say the assignment first, right? You want to assign expression 1 to this variable if the condition is true, otherwise expression 2. So you can combine these into 1 line like this. You put the if-else at the end and put this major action in the front. It's very similar to the list comprehension we're going to encounter later, where you can put the filter or map on the list of items. And these are the filters, like conditional filters. Like if you only want to output numbers that are even or something like that. So you can put those conditions here. So this assignment will be true or will be executed even if and only if the condition is true, else I will have to assign expression to the variable. So this kind of construct you need to be pay attention to for if you're coming from other languages, is unique in Python, right? Any questions? Okay, I think this chapter should be fairly easy. Just need to avoid, a lot of nested loop. I will give you some extra homework to do where you may solve it to use a lot of if-else statement, but it's better to do it, without. Okay, let me talk about this lab seasons, right? So this lab is interesting. You may need a lot of if-else statement for this, but there's a better way to do it, okay? In terms of less code and more, clear data structure. So the problem states as follows. Write a program that takes the date as input and output the date season. The input is a string to represent the month and int to represent the day. Okay, string is the month and say like April 11. So April is the month, 11 is the day. And you should output the string spring. You also need to check if the input string are valid. So if the input is blue and 65, obviously it's out of the bound and it doesn't make sense. You should reject it. You should say invalid. So this assignment looks for your ability to check user input, right? User input is always important part of the things. So how to approach that, okay? And they give you some, information on the dates for each season. You should, take notes for it, okay? So let's get started. Lab 3, what's the lab number? 312, okay? Hi. So how to approach this problem, right? First of all, of course, I like to put the problem statement here in the comment section, so you get some reference, right? So first of all, they ask you to check user input. Now, where is the user input? What's your input? The input are 2 lines. One is the string, which is the month, and the other is, so month is equal to input enter month, right? So I'm prompting. In your Zybox, you probably don't need this because it will output something in the console and may screw your data. But when you work on your own IDE, you should put there so it's clear that what you're asking for. And the day is equal to, so you want to convert to integer, right? Input date of the month. Okay, so that's taken care of. And now, then you want to check. First of all, well, I want to check for invalid output, right? So how to check invalid output? Yeah, input. So what are the legal input for seasons? Spring, summer, autumn, and winter, right? So I'm thinking maybe I should have some data structure where I can check against. You can for example, if I say for seasons is equal to, like, I don't know, a list of like summer, spring, winter, and is that, let's see, autumn. Okay, so that's your 4 seasons. If, okay, now you're using branching, right? So you can check if month so if month is in one of the 4 seasons, right? Then your input is valid, right? Now you can also do the reverse logic. If not, that means if month is not in this 4 season, you wanna do, I would print what is the required? It says invalid, right? You want to just say print invalid and quit. Okay. Yeah. Else, you can say else if so month is, so else if here, if you are here, that means the month is valid. However, you want to check the date, right? Now you can use a similar technique where you can predefine a day, right? You can predefine a day for each month, right? You can check these dates, okay? And you can do something about it. So there's a lot of checking, which I don't like, right? There is a lot of if, else statement. What is a better way of doing that? Well, I'm thinking about maybe I should, encode these data into some kind of data structure so that I can get some, boundary checking or something. Otherwise, you can, normally what you do is if, let's say, depends on the month, right? So if, for example, months, well, actually, there's one more thing here. So your input months, right, need to be exactly match this season, capitalized. But sometimes the user are, sloppy and they give you a lowercase. So maybe you can do capitalize to basically capitalize it, right? So, you can even capitalize here. Capitalize. Yeah, you can capitalize here. So I don't need to, do that every time here. So just do the once pre-processing. Okay. Let's actually try it. See, the good programming habit is to write a little bit of code and test it right away, right? So you don't want to wait until the last minute because you may have some error already, right? That will save your time in the long run, right? So Python, let's see, lab32.py, enter months. Let's say, oh, wait a second. Yeah, there's one more thing. Months is actually not the season, sorry, it's the 12 months, right? So for season, I guess, let's say, so there's an error right there, right? Bug error. Let me just date of the month, like 12, so invalid. So of course, it's not gonna match the summer, spring, or autumn. So you need to print all 3 months, like January, I don't know, February, right? This kind of thing. Yeah, that's March, and so on and so forth. So April, and so on. So if then you can just check if your input is one of the months, right? 12 months. So there's not 4 seasons, but like valid months. Okay. So here you want to say if not months in valid months. Okay. So in this case, you would check if your input is one of them. So I still don't like that, right? What I want to do is I'm gonna using a different data structure. Okay, I can keep this input, right? My input is good. So I want to have a season data structure, which is a dictionary. And you already learned something about the dictionary has a key and value, right? So my dictionary will have the 4 season as a key, spring, okay? And what's my value? Well, I'm thinking, so spring is March 20 to June 20th. So they has months and days, right? So how do I encode this into my value? Well, there's a key and a value. So March, right? So in the month of March, I will have certain days, like from 20 to whatever, the end of the month March, that belong to March. And June, 1st to June 20th also belong to spring. So I want some kind of data structure where I will capture both the range of date and also the month's name, right? I can certainly do that. I can do a dictionary inside the dictionary. So my value can be another dictionary where I can do March, okay? And then I want a list of dates. So the dates is from a range of 20th to what's the last day in March, 32, right? So I have a list of dates for March, okay? And that's it. That's the basic data structure I want to encode with. So you can keep, wait a second. Yeah, so we are not done yet, right? So not only March, but we also have April. April, we have a list of range of, so the entire April, like April 1st to April 31st are considered spring. And then, let me just align this better, right? So now I have May, entire month of May, we have range of 1 to 32. Okay, May 32, you have to check on that. Yes, and then finally we have June, right? June and list of range. We can have June 1st to June 21st. Yes, June 21st. Now, why 21st? Because it ends on 20, right? Remember the range function, it don't include the last item. So 1 to 21 will give you 1, 2, 3, 4, all the way to 20, now 21. And here it's the same, it's going to 31, now 32. Okay. So that's some details. Okay, so that's that. And comma. So basically, that's just the one season, right? Remember that the master key is the season name, spring, and the value is another dictionary where inside each dictionary, each item has a key of month and value is a list of integers representing days, okay? This is just one of them. And you can do like another one, summer, okay? So summer, you have another dictionary, okay? A dictionary contains, let's say June from list of range 21, right, to 31. And another one is July, right? July list of range from the entire month of July, basically. Right? And then you have August. You have a list of is August. Yeah, entire month of August. Right, so 32 as well, and so on. Maybe September. So September, we're on September now. Oh, wait a second. List of range of 121. Okay. All right. So that's. So I'm gonna leave up to you to finish this dictionary. Okay, you can do the same thing here. So spring, you have March, April, May, June, and the summer. Let me just make an indentation. So although this is just for, clarity, I would like to do it that so that, you can. So summer. So yeah, that will be clear which level it belongs to the master key, and then which one is the second key. All right. Okay. Let's see. All right. So double check your comma, comma, comma. Yeah, that works. All right. I want to be consistent, so this comma goes here, and this comma goes here. So I don't need this comma. I don't need this comma. All right. Very good. So you can fill out the rest of the data structure. Now we have a season encoded here, right? Month is input. I'm going to capitalize it. Okay, let me just make it. All right, yeah, day is that. So now what's next? So these are the keys, right? Spring, summer, and winter, and so on and so forth. So now you haven't learned about for loop or iteration yet, but you kind of see me doing that in the Taste of Python lecture 1, right? So the simple concept is iterated through a dictionary. Don't worry if you can't do this yet, but we will talk about iterating our data structure, list array, list tuple dictionaries later. But you can do for key in season. Okay, so now you have a season dictionary. What are you gonna do? You want to have something, right? Okay, hold on. What's going on? Oh, yeah, indentation. See, this is key. You have to have this flush with the rest of the thing. Oh, yeah, you are missing a. Yeah, okay, here you go. For keying season, so that means you are iterating through spring, summer. Okay, yeah, this one's weird. Why there's I here? I think I accidentally put it there. Oh. All right, let's just in the comma. Come on. All right, I can just do that. All right, taken care of. So yeah, for key in season, that means we grabbing all the keys one by one. So for each key, we'll grab an inner dictionary here, right? So let's say data is equal to, for each season, right? Season key. So basically for that key, I get the value, which is the dictionary, right? And then once I get the data, which is, remember, it's a dictionary. So let me check if months now, months in what? In the subkey for that dictionary, or the key for that sub-dictionary, right? March, for each key, March, April, May. So this months will be in that key. So in data, that means the data, remember, is the dictionary of, say, in spring, you have 4 keys, and then month in data. If month in data, that means that's a valid month. And there's a logical and day, right? You have to check the month, not only months, and also the day. So I got the months, but also the day have to fall into those ranges. So day in the ranges is the data of that month, right? You found the month, which is the key. Say the month is April, then you in the April, you found if it's within day 1 and 31st. Okay, so data April represents the list of numbers. If that date falls into that number, then that's a valid answer, right? And then you find it. You find the key. Now there is some. So you don't need to iterate through the all seasons and all keys. If you already find it, you can break early, right? You can break early. And if you break early or you finish them, you grab it, right? So I need to somehow to indicate that you find the correct month and date in that season. So I can use a flag called found equal to 0. So initially I didn't find, I used a 0, but I can use a false, right? I didn't find it. I can use a Boolean. If I find it, then found equal to true. Okay. So now, once I'm out of the for loop, right? I search the every possible combinations. If found, okay, if not found, if I didn't find anything, that means it's invalid, right? You can print invalid. Okay. That's something to think about. Otherwise, else, right? You can use else, or you may not. Then that means you found it. What you wanna print? The answer needs to be the season, right? So you need to print the key, right? So maybe I shall use another variable to store the key, right? Because that's found, and when you found it, that's whatever key you are in, that's the key you need to grab. So season or S season. Let's see. I can avoid, so I name the seasons, and then season equal to, I don't know, empty string, right? And so found equal to true, season equal to key. Actually, let me put it here. Season. That's the current season I'm searching for, right? So I don't need to worry about if it didn't the key and they find this, then your season is already there. And let's see, it goes through this again. Next. At the end of the thing, you can find it, right? You find it. So it doesn't matter where you put it, the season is always good. Okay, that's good. So just print season. Okay, print season. Yep. So that's it. Let's see, there is some problem with this additional curly braces. Okay, so you got it? So basically a good data structure can save your time in the long run, right? So you can see you have a dictionary of dictionaries that you can use to grab the key and value. And the value is another dictionary, which is this data. And this data has a key and value too. And so month is the key and day is the value for the data. Okay, and so on. So let's run it. Python lab 3 pi enter months. Let's enter the months in the known dictionary. Let's say April 1st, just 1. Yeah, it's a spring, right? It's still a spring. And run it again. Let's do like September, right? And let's say today is 14. Hey, it's still summer. Okay, enjoy when you can. All right, so that's for this detailed solution for the lab. Hopefully you get some idea. You're not required to do that because you don't know the for loop yet. But yeah, just give you some idea on what's possible out there. Okay. So let's look at, I don't know, another lab maybe, shall we? Or I think we talked about the exact change before, right? Let's see, do I have that already? I don't think so. All right, let's do it again. Let's call it lab 3.13.pi. All right, so again, some requirement. All right, so where is this? Okay, exact change. Write a program with total change amount as an integer input, and output the change using the fewest coins, each coin type per line. The coin types are dollar, quarter, dime, nickel, and pennies. Use singular and plural coin names as appropriate, like 1 penny versus 2 pennies. So right there, you will use some if statement, right? Say if your number of pennies is greater than, say like if you have one, number of pennies 1, then you output penny. So if number is equal to 1, you say print like, penny, right? Something like that. This is the variable format, none, okay? So something like that. And else, if that number is greater than 1, right, you can print like pennies, okay, and format it. Okay, so basic idea is you have some, branching to do. Depends on what, number comes out. You can you can print different format, right? You need some space in between probably. Okay, so that's that. Now we already talked about how to do this coin exchange problems before, where you use the integer division, keep divide. You start with the biggest coin, like dollar, a quarter. So then you are guaranteed that you get a minimum number of coins to change. Right? Now this is not always the truth, but for this particular problem it is. To be more precise, or you need to use some techniques that we won't talk about in this course. Something called dynamic programming, where you try all solutions and pick the best one using some kind of optimization technique in the middle. You always pick the optimum one and you populate down the road, right? So, but here it's sufficient just to use use the biggest coin first to calculate your number. For example, if you have, say, amount, right? The initial amount is input, for example, enter total amount, right? You can use a dollar sign, but you want to, let's say, convert it to cents, right? So maybe you can think about, like, for example, you have, I don't know, what's the input, let's see, total change amount as a integer input and output change. The quant type of dollar, okay, use a singular plural form. So the input, they didn't give you the unit of input, right? So, but here you again cents, okay? So in cents. So that's, you don't need to convert to cents, right? Otherwise you have to convert into cents, right? So then you can just direct convert it to a cent. All right. So that's that. And then number of dollars, you can use different variable for dollars, is equal to amount, say integer divided by what's a dollar? 100 cents, right? So every 100 cents is a dollar. So you can see how many cents you can do an integer division, right? The reminder will be something to be divided by something else. So amount equal to amount, 100. So that's a reminder, which is the number that you're gonna do next. So number of, then you can try a different coin, like I don't know, quarters is equal to amount divided by what, 25, right? And then amount is equal to amount modular 25, for example, and so on and so forth. Now you can see the pattern. There's some repetition in this pattern, right? So in order to save or to make your code more succinct, now of course again you haven't learned iteration yet, for loop or whatever, but in the future if you learn that, you should rewrite your program to make it more structural or modular, where I can suggest a structure called the exchange table, right? Exchange table, which is another dictionary with the key like dollars, and the value is which is basically how many cents in a dollar, right? 100. Okay, and then for example, quarters, yeah, and the value is a 25, for example, right? And so on and so forth. So you can keep this list, keep this dictionary. What's next? Dimes. Okay, we know dimes is 10 cents, right? And nickels is what? Nickel is 5 cents. And of course, penny. Pennies is 1 cent. Okay, so now once you have that, you can simplify this by number of dollars. You don't you can say divided by, now this is like let's say for key value in exchange dot items. You'll learn that later. So basically give you a key value, and none is equal to amount divided by the value, right? So the value is a variable now, where in the first it just get the dollars and divide the value. Value is 100, right? 100, and then amount equal to amount modular the value, right? So now you get the next level, you get a quarter, and you divide. So you can just reduce that into these two lines and delete them. Okay. Now, of course, you want to save that to something else. Otherwise, this number will be overwritten for the next loop. So you may want to make a number a list, right? Number equal to a list. So you can append. You can append this, right? Append the value to it. Right? You keep appending that. So that's the beauty of data structure. You can keep appending it, and so you just know that now when you want to print out, right? You can let's just print number, right? Let's see what's going on here. Let's run Python lab 3.13.py. Okay, and the total amount, let's say 45. Okay, so 01200. What does that mean? Okay, $0 obviously didn't reach 100, and 1 quarter. Okay, 1 quarter, and 2 dimes, and 0 nickel, and 0 penny. Right, that's the interpretation. So once you get the number, you can just iterate through this number and just print out the so you can iterate like for I in num, right? So basically for each item in num, and remember you have this key, right? For this key here, you can so you don't need to print if it's 0, right? So then another branching. So if I is not 0, let's say if I is not equal to 0, so you can have a nested loop. Let's do that nested loop. Although I you know, I think you can do it more precisely if I not equal to 0, right? Because you only print when it's non-zero. Okay, it's positive number. Or you can say greater than 0, right? It's a positive number. You know, it doesn't make sense. You have a negative pennies or negative anything, coins. So if it's positive, then print. Now you can use this thing, right? Print like okay, let's see output. Let's make a string, right? Output equal to let's say num, okay, plus the key in that. So you have to somehow know your okay, so basically you want to know this I, no, and also the index of the position, because you know the position corresponds to quarter or dollar or whatever, right? So let's see what's going on here. What's going on here? You may want to not put it into a list because then, you know, how do you know which position cost? You have to know like 0 position equal to dollars, right? And thing. So you probably need another dictionary to do this kind of things, right? So maybe you want to make another dictionary, okay? Because I want the 2 things, right? I want not only the amount, but also the change. So, so what I can do instead of append, I can do number dot insert, right? Dot get key. So you can use a get method to get the key. So basically, the key is still like dollar, quarter, and nickels, something like that. But the value will be how many coins, right? How many coins? So we can reuse the key, get key, right? And zero. So we want to get the, so initially everything is empty, right? And we want to insert numbers in it. But the problem with the dictionary, empty dictionary, is if the key is not there, you will encounter errors. Say, I give you an example, Python. If I say number equal to empty dictionary, and I will say number dot get, let's say dollar, So it didn't. Okay, so let's assign it. V equal to number dot get dollars. So V is like nothing because it's empty, right? But if I do another way, like dollars, so there's two ways of getting it. You'll get the error, right? Because it says key error. There's no dollar key in that. So I can do this, like if number of get dollars, not get dollars, get key, right? Key is the dollar quarter to represent that. If that is, let's see, we equal number dollars. What's the type of V? It's none, right? It will return none. So if not none, right? If not none, that means so if that is none, right? If it is none, let's see. I don't need this parenthesis. So if it's none, then not none is true, right? Then I will deal with that. I'm gonna say number of key. Can I do this? Let's see. Number of dollar is equal to 1. Yeah, I can do that. So you can assign this. Now, if you do none, it will say $1. So number of key is equal to the value. Not equal to the value, equal to the what's that, amount divided by V, right? So I calculate the number of coins, I put it there, right? If I already, you know, because you just put it in, you can't have any key in it. So this one should be suffice, right? If you already get the number, you don't need to populate. Now I can print the none, okay? And let's run it. Okay, clear. Wait. What's the, there, 45 cents. Okay. Oh, here we go. Wait, amount of okay, so so yeah, so what the annoying part is that if you have empty dictionary, you want to you know, insert a number, and if the key doesn't exist, it will throw a key error, right? But if I do get key 0, let's try it out, okay? Python, like number is empty, and number V is equal to number dot get. Let's say whatever, KK 0. Number of KK is equal to 1. Yeah, insert it. What's going on? If not number get, let's say BV, that should be none. print, print number of BB equal to 3. All right, so number, yeah, that works. If not, number get K. Number of K is amount divided D. I still use the assignment. Okay, so there is some, error here, but okay. So clear. Come on. Wait, where's my? Oh yeah. All right. So yeah, this should be assignment, not equal. Okay, and let's run it. 45 cents. Now you can see this answer is $0, 1/4, 2 dime, 0 nickel, and 0 pennies, right? Okay, so now when you print it, so now you can iterate through this dictionary, right? For, again, key value in num about items. So now you have the key. What's the key? The key is dollar, and the value is the coins, right? So if I say number of key, the key is guaranteed to exist now because you're iterating the actual keys here. If that's greater than 0, right? Greater than 0 is a positive number, then you're gonna print out. So your print is the value, right? The value and comma and the key, right? The key is, okay. So let's try that. Okay, let's try that. So 45 cents, you can see 1/4 is to that. Now, you still need to figure out this quarter versus quarters, right? You have to maybe, replace a different words with that, but I'm not gonna finish that for you. You have to think about this. But again, you see this code is really short, right? Only 20 lines, actually, minus this comment. So yeah, I mean, you can see the data structure plays a great role in shortening your code. So I hope that you can make use of that. All right. So at the end, I want to give you a homework or exercise that you want to do, which is called a game. It's called rock, paper, scissors, lizard, spark. Right. You all know how rock, scissors, paper game work. So basically, you have n number of states, and the opponent will have one states, and you will get another state and see who will beat who, right? So this is a rule for this rock, paper, scissors, lizard, spark game. Okay, you need your task is to come up with a game. Computer will randomly generate a number, represent one of the 5 states, and you get a user input. User don't know, right? User gave you his input as a number or a string, doesn't matter. You can convert a number to a string, right? And then you can compare. Now you'll have to come up with some rule to judge who wins, and then you output who wins. So simple task. However, there's some good techniques that's involved, like modular arithmetic. So think about how you're gonna convert these 5 states into a number and how to compare. Because when you compare numbers, it's much more easier, right? So yeah, think about it, and I'm hoping to see your implementation soon. Okay. Yeah, that's for all, and I see